Alright, so this entire example is an example of a combinations type. Specifically, a type when we want to look at groups, committees, subcommittees, and so on. You can read those. So groups, committees. So this is an example like those types. So if you see the phrase, we're just going to pick a random group of people, I'm going to pick a committee of people, I'm going to pick a subcommittee of people. This is a case that goes with those. And on those cases are always combination types, because if it's a random group of people, items, or things, it's always combinations. Because it doesn't matter if you're first, second, third, or fourth. Order is not important, right? Order doesn't matter, right? As long as you're in the group on the committee, that's all that matters. Whether you're the first person picked for the group or the committee is the same as if you were the last person picked for the group or committee. You're all on the committee. You're all in the group. Right? And so this is an example of that. All right. So a simple example is we have members at a high school drama. All right, there are 5 seniors, 6 juniors, 3 sophomores, 7 freshmen, a group of 4 is to be selected to represent the club at a conference. So this is just a random group of 4. There's no rank or order to it, right? I am just picking 4 people from the drama club to go to the conference. If you were the first person picked, you're going to the conference. If you're the third person picked, you're going to the conference. Doesn't matter what order you picked in. Alright, so order is not important. Secondly, I want 4 people, right? So I can't pick the same person twice. If I picked the same person twice, I wouldn't get 4 people. I'd get 3 people, because I picked somebody 2 times. They're still just one person. They just happen to take up 2 slots. Right, but I'm not allowed to do that. I need 4 people. And so it's subtle, but whenever I want a group of people like this, and I want a set number, no repeats allowed. Alright? So that makes it a combinations type. So this entire problem is a combinations type. It's going to be doing combinations of the universal set and then subsets of those combination groups of this universal set. Alright, so we'll figure out how many total people, total students. So I've got 5, 6, 3, 7, so 21 total students, and we want to pick 4. Alright, so how many groups are possible? Well, this is my universal set. Out of all of my students, how many ways can I pick 4 of them? Alright, so this would be the universal. My set S, so number in set S, which means I can pick anybody. Well, there were 21 people I could choose from, and I'm going to pick 4 of those 21. And so it's combination out of 21, I choose 4. So again, on the calculator, you do want to use the calculator on this. All right, there's really no other way to do it. Combinations, you use the combinations formula. All right, so 21, combinations, choose 4. So out of 21 people, I'm going to select 4. So the number in my universal set, number of different ways total, well, there's quite a bit. That's why you couldn't really list them. There's almost 6,000. There's 5,985 different groups. Alright, so that's the total. There are total 5,985 different groups of 4 if I'm selecting out of 21 people. I covered up the last example. Next example. Alright, so that's the universal. The rest of these are all going to be subsets of that, so they all should be less than 5,985. Alright, so the first subset is I want a group of all freshmen. So how many of my 5,985 are groups of all freshmen? Well, I'm only selecting freshmen, right? And so there is now, instead of looking at everybody, I'm only picking freshmen. Well, there were 7 freshmen. I still have to pick 4. I'm just picking 4 from the 7 freshmen. Alright, so number of ways to get all freshmen. Well, it's still a combination, but instead of picking out of all 21, I'm picking out of 7. I'm still choosing 4. I still have to complete my group. So it's 7, choose 4. So it's 7, combination, choose 4, which is a much smaller set. There are 35 all freshman groups. You can read that. Good luck. Alright, so out of 5,985, 35 of those contain all freshmen. Alright, so those are very small odds. Very low. If you're just randomly selecting people, it's very little chance that they'll be all freshmen going to the conference. Alright, how many groups include a member from each class? That means I want a member from the senior group, the junior group, the sophomore group, and the freshman group. Alright, so this is a subset where I get 1. So 1 senior and 1 freshman. Or let's do them in order. 1 junior and 1 sophomore and 1 freshman. Alright, so sophomore SP, freshman. So this is an example of where I'm going to use my and or statement, my multiplication and addition principles with the combinations formula. Right? So remember, when I use the word and, I multiply. When I use the word or, I add. And so these are and. I'm picking 1 senior and 1 junior and 1 sophomore and 1 freshman. Well, to pick those, I'm doing combinations. So combinations, I'm going to choose 1 senior. So I'm picking 1 senior out of 5. So combination, choose 1 senior out of 5. And combination, so I'm multiplying because it's and. Combination, I'm picking 1 junior out of 6. And combination, choosing 1 sophomore out of 3. And I'm going to pick 1 of the 7 freshmen. Now, technically, it is combination. If you typed it in the calculator to do 5 combination, choose 1, or 6 combination, choose 1, 3 combination, choose 1, 7 combination, choose 1. As it turns out, when I'm only choosing 1, it's 1 out of my total. It should make sense. The number's going to come out whatever my total was. If you type it in and verify, check that I'm telling you the truth. If you type in combination 5, choose 1, it comes out 5. There are 5 seniors I can pick from. There are 6 juniors I can pick from. There are 3 sophomores I can pick from. And there are 7 freshmen. And so how many ways can I get a member from each group? Well, it's 5 times 6 times 3 times 7, the number in each one of those groups. And so you just multiply. It's a straight multiplication. 5, 6, 3, 7. And so when you multiply that, that comes out to 630 groups with 1 member from each class, meaning I have 1 senior, 1 junior, 1 freshman, 1 sophomore. So out of the total 5,985, 630 of those contain 1 person from each class. All right, next example. How many groups include exactly 2 seniors and 2 juniors? So again, I'm picking a specific type of group. I want a group that has all upperclassmen, specifically 2 seniors and 2 juniors. And so again, this is the and statement. So number of ways to get 2 seniors and 2 juniors. It's all combinations. So it's combinations. I'm picking 2 seniors out of 5. There were 5 seniors. And, so we multiply. I went 2 juniors out of 6, right? There are 6 juniors. So I type those into the calculator. I do combinations 5, choose 2. Figure out what number that is. Combinations 6, choose 2, and times that together. All right? So combinations 5, choose 2. If you multiply that, or if you put that in the calculator, it should come out 10. And then times, because we're using the word and. If you type in combination 6, choose 2, that should come out 15. Alright, so there are 15 ways to get 2 juniors. There are 10 ways to get 2 seniors. And then to get my complete group of 4, it'd be 10 times 15. So there's a total of 150 groups with exactly 2 seniors and 2 juniors. Alright, next example. How many groups include either all seniors or, so this is the first one where we use the word or, all seniors or all juniors. And so there are 2 cases. I want a group of all 4, right? I'm picking 4, I always have to complete my group. Right? I always want a group of 4. So all seniors, meaning I selected all the people going were seniors, so I picked 4 seniors in my group. Or I picked a group with all 4 being juniors. Alright, so number of ways to get 4 seniors in my group, or number of ways to get 4 juniors in my group. Alright, so these are 2 separate outcomes. That's why I separated by the word or. Remember, we separate with the word or, we use addition. Alright, so the first one is I'm selecting 4 seniors out of all of my seniors, right? And so it's the combination, I pick 4 seniors out of 5, right? There were 5 seniors to choose from, so combination out of 5 seniors, I'm picking 4. Or, so we add, I'm picking 4 juniors out of all of my juniors, so all my juniors were, I've forgotten, 6. Alright, so combination 5 choose 4, those are all the groups with seniors. Or combination 6 choose 4 are all the groups with all juniors. Right, type those in the calculator, so 5 choose 4 combinations and 6 choose 4 combinations. Alright, this comes out 5, which means there are only 5 groups out of my 5,985 that contain all 4 seniors. I add to that all the outcomes where I've got all juniors, and so again, put combination 6 choose 4. If you do combination 6 choose 4, that comes out to 15, and so that 15 means there are 15 groups that contain all juniors. So 5 groups with seniors, all seniors, 15 groups with all juniors, so that's all of the seniors, all of the juniors, so all of the seniors, all of the juniors, so there are 20 groups total that are either all senior or all junior. We actually know how it's split up. 5 of them were the all seniors, 15 of them, so there's more all junior groups, because there are more juniors to pick from, right? Having one more person in the junior group made a big difference. I had 6 juniors to select from versus the 5 seniors to select from. Alright, there's that at least phrase I said you're going to have to get used to in this class. We want at least 2 sophomores. So that's a minimum. I want 2 sophomores or more. So I want 2 sophomores or more. Well, if we remember, we'll go up to the top. If I can get there. On the computer. Oh, too far. There's yesterday's notes. There we go. Sorry about that, guys. There are only 3 sophomores. That's where I wanted to get, 3 sophomores. Which means, when I get down to this example, I want 2 sophomores or more. Well, or more would meaning 3 sophomores. So I don't really want to use the complement. You could. The complement would be taking my universal set, which we found in part A, subtracting away the cases we don't want, which is the case with 1 sophomore or no sophomores. And that's fine. If you choose to do it that way, you can. This one I'm not, because there are only 2 outcomes I'm looking for. Alright, so I want the number of ways to get 2 sophomores or 3 sophomores. Now, I left a little blank spot here because if you remember, we always want to pick 4 in our group. Right? We always want to have 4 people to go to the conference. So we need to complete our group of 4. So I left a little blank spot, and I might not have left myself enough of a blank spot. I might move these over a wee bit. I have to complete my group. So if this first group is 2 sophomores, well, I still need 4 in my group, so I still need there's a hidden and statement. That's what makes these harder, these types harder. I need and I have to complete the rest of my group. I need 2 others. And I write the word other. That other means other than sophomore. So these cannot be sophomores. right? I've already picked 2 sophomores. I don't want any more. And so when I pick my other 2, they can't be sophomores. So they have to be seniors, juniors, or freshmen. Or, alright, so that's the first one, first group of 4, 2 sophomores and 2 others. Or I get more, right? The more would be 3 sophomores. That's as much as I can go because there's only 3. But I still have a hidden and statement. I have to complete my group. So if I have 3 sophomores, I need 1 other. And remember, the other means they're not I actually don't have any more sophomores to choose from, so I can't pick a sophomore. All right, but that's what you have to make sure you keep in mind. I need other than sophomores. All right, now I fill it out. Make sure I use multiplication when I do and, addition when I do or. Right, and this time I've got ands and ors. Alright, so first I'm picking 2 sophomores. So combination, I'm picking 2 sophomores out of 3. And I need 2 others. Alright, 2 others, which means I need my seniors, juniors, and freshmen. Well, there are 5 seniors, 6 juniors, and 7 freshmen. So when I add 5, 6, and 7, that means there are 18 others. So I picked 2 of the 18 others. Or I could have taken 21 minus 3. That would have been faster. Or, so now I do my addition. I pick all 3 sophomores. And I still need 1 other. So and, which means I multiply. I need 1 of the other 18. Right? The 18, remember, are the non-sophomores. So I'm picking 2 non-sophomores to fill out my first group and 1 non-sophomore to fill out my second group. Alright, so combination 3 choose 2. I'm picking 2 sophomores. Combination 18 choose 2. I'm picking 2 people that are not sophomores. Or, so we add. So or we add. I'm picking all 3 sophomores. So choose 3. And, so we multiply 1 that's not a sophomore. Alright, now you type it in the calculator. So combination 3 choose 2. Type it into the calculator. That comes out 3 times combination 18 choose 2, and you do combination 18 choose 2, that's 153. Alright, that's all of the groups. So when I take 3 times 153, and I'll do that at the end, that would be all of the groups that had 2 sophomores. Or, so we add, the groups that have 3 sophomores. Well, there's only one way to pick all 3 sophomores. If you type it in, you always, double check it, type it in your calculator. But there is only one way to pick everybody, if it's a combination type. If I pick all 3 sophomores, there's only one way to do that. And 1 of the 18 that are not. Remember, if I pick 1, it's always the total, right? There's 1 out of 18, so I had 18 choices to fill out that last spot. Alright, so I take 3 times 153, add 18 to it, and that'll give me my final answer. So 3 times 153 plus 18 comes out to 477 groups with at least 2 sophomores out of my total. Right, at least 2 sophomores. Some of them, actually most of them, had 2 sophomores. Only 18 of them had all 3 sophomores. Right, that's how it's broken down. But those are all of the groups where I have at least 2, which means 2 or 3, 2 or more. Alright, the last one from this example. How many groups include? So at least and at most, are phrases you're going to want to make sure you're familiar with. They're the tougher phrases, but they show up all the time in counting, and they'll show up in the Chapter 7 probability, and they'll show up in the Chapter 8 statistics stuff. Alright, at most is the opposite of at least. At most means that's my maximum. I want 1 senior or less. Well, the only way to get less than 1 senior is no seniors, right? So I want 1 senior or no seniors. Alright, so again, I'm going to set this up, and I'm going to leave myself blank spot because they're a hidden and statement. Remember, I always want to pick 4 for my group. So I've got to keep in mind, I've got to always finish my group. Alright, so I want 1 senior or no seniors. So number of ways to get 1 senior. Well, there's a hidden and statement. I still need 4. I have to finish off that group. So if I've got 1 senior and only 1 senior, I still need and 3 others. All right, remember the others are not seniors, right? They cannot be seniors. They've already picked a senior. I usually just use the word other. Other implies other than the one I've already selected. Or, right, that's my one group of 4, right? I've got 4 people there. That's one group. Or I get a group with no seniors. So if I have no seniors, that means all 4 are not seniors. Right? They're all 4 from the other group. Alright, and now I fill it out with my combinations formula. Alright, so combinations first. I'm going to pick 1 senior, so I'm going to pick one of the 5 seniors. And then I fill out my group with everybody else. So 3 of the others. Alright, so I've got to pick the juniors, sophomores, and freshmen. So there's 6 juniors, 3 sophomores, 7 freshmen. So there's 16 others. I've got to pick 3 of those. Alright, and there's one group, right? I've got the 4 people in that group. Or, so now I add combination. I pick 4 of the 16 that are not seniors. And that finishes out my second group, where I've got no seniors in it. And then I type that out on my calculator. Alright, combination 5, choose 1. Well, that's just 5. Alright, combination 16, choose 3. Well, I'll have to type that in. That's probably a fairly large number. So combination 16, choose 3 is 560. Plus combination 16, choose 4, which is 1,820. Alright, so there are 1,820 groups with no seniors, right? That's what this represents. Whatever 5 times 560, that would represent all of the groups with 1 senior. Alright, so it's going to be a fairly large set. When I multiply them out, 5 times 560, add the 1820, it comes out to 4,620 groups with at most 1 senior. Alright, so that's a lot of them. Remember, our total was 5,985. Alright, so the odds are pretty high in that case that we're going to have a group with at most 1 senior. Alright, so that finishes up an example where the entire example was combinations. Alright, so make sure you understand this. Whenever you see where we're selecting a group of people, and there's no rank to them, whenever it's a committee of people or a subcommittee of people, it can also be groups of items too, as long as there's no distinguishing feature between them. It's the combination type, so it's this type of example. Alright, so make sure you look it over and understand this combination type. The next one is I'm going to look at a group of people where it's a permutation type, where order does matter. Alright, so let's stop there and we'll pick that up in the next set of notes. Will be the permutation type.